Hello guys, welcome to this new video. Today I'm going to show you how to simulate with a Proteus file to simulate a relay as well as a LED indication. Once you have launched the simulation, the Proteus file like that, just go up there and click on the icon of ISIS down to draw the sketch. Okay, once you have opened, now we need now to import the component from the library. Just click on component mode and then open it, press there and go here. Now we need, for this project, we need a relay. Just press, and in order to simulate very well, you need to select the active relay. This should be active, not this one, because the simulation will not run very well. Just select the active relay, select it, just make a double click, and then you import it inside the library and you will see it here, the list of material. Okay, we need also the LED to indicate the level of the voltage. I'm going to select LED, light emitting diode. As well, we are looking for the active LED. Just I can select maybe the green, or it depends of me. Let me select maybe green LED. Double click and you see it there. We need a resistor to limit the current flowing through the LED light emitting diode. Just press res. We don't need to be active or not. Just select the resistor. We need also the transistor because we know the name of the transistor. Let's select the BC547. okay, and you can see the package there. Just double click twice. We need also the freewheeling diode to protect the coil of the relay. That we are going to select the diode 1N48 N41 which is the Zener diode, not Zener diode, the signal diode. We can also select maybe 1N4001, will still be the diode, or 4007. The only difference is that the level of the voltages. You see that for this silicon diode, the voltage can reach 1 kilovolt. Why the one for 1N01, the higher voltage is only 50 volt. That is the main difference that you can have. Okay, what we will need again, if we need something again, we are going to come back again and select. So we are going to first of all put the relay, transistor, which is the NPN Transistor BC555. Okay, let me select, put the relay. We have there the coil, as well as the resistance for the base to the base. We need also a pull down. We need also the pull down relay. Just press the key, positive key, plus key on your keyboard to rotate the component. Okay, we need also the freewheeling diode with this one, and you need to check the polarity very well. Let me shift a little bit, select this selecting key, shift a little bit so that I should have a good space. Okay, we need also to indicate the supply. Then I'm going to select the LED. That is it. Press key plus on your keyboard and change the direction. That is it. I need as well the resistance to reduce the current flowing through the resistor. We are going to come back and adjust all the value. Then click here, the plus, and start interconnecting the drawing. Let me shift this LED so that I will have a nice view. Okay, and here is the relay. We are going to connect it like that. And here you are going to put the ground. You just come there and select ground, just to make a reference of the voltages. D'accord. Now here will be the supply. Let's all go and to take power. Okay, and that power will be 12 volt. You can indicate the level of the voltage, just say 12 volt, enter. And this input will be controlled by just say Arduino or a toggle push button, and this resistor should be 10 kilo ohms, and this one will be 2.2 or 1 kilo ohms. Okay, and this transistor, correct. You have already put all the part. Now you can to see how it's working very well. We can put the bulb here, the lamps here. So I'm going to take another component inside the library. Let's say lamp, active lamps. Okay, I will need also the supply source. I'm not sure whether there is a source there. Sine wave source, V source, that is it. Okay, now you need to put the source there and then put the lamps. Where is that lamp that we took? Then change the direction and interconnect here. Why this one is normally closed means that you are going to take the normally open and interconnect like that, and we can modify the characteristic of the source property. The source here is for DC, the amplitude, the frequency. Let's say the amplitude here will be 220 volt. Okay, the frequency will be 50 hertz. 50, we don't need to precise. The delay time we don't need, just keep it like that. Okay, and the lamp here will be 220 instead of 12 volt. Let us say 220 volt. Okay, so we need, so for to simulate this, we are going to have two positions. It can be from 12 volt, and let me say, let's say we take a switch, switch, that is it here. Okay, let me close. That is it here, correct. Let me add it again. Means that because this one is a NPN transistor, he will need the positive voltage in order to saturate this transistor. And when the transistor will be saturated, this light, this bulb will come on, and the coil of the relay will be energized and close and change the position, and this light bulb, 220 light bulb, will come on. Let us launch the simulation by pressing this key button. Launch like that. No supply specified, net 12 volt. Say that there is nothing specified design. There is no problem. We are going to solve this error. No supplies, no power supply specified for 12 volt in the power array configuration. Okay, in order to solve this problem, we are going to change this 12 volt source. Let's just make double click right 2 times and delete. We are going to replace it by a DC source. Let us go to source and take DC source, put it there and connect it there, and modify the value. The level of the voltage here will be 12 volt. Okay, we can launch once more the simulation and see how the polarity is. You see that you have a positive voltage and the reference of the voltage. When you close the switch, the system will send enough current to saturate the transistor. Whoa, that's the only problem that we have with Schematic, with Proteus. When you start working, it just disappear like that. Let us launch again once more. Okay, recover automatically, yes. That is the main problem that we have with Proteus. When you start simulating, the thing just disappear alone like that. I was saying that we are going to replace that thing by a DC source. Let me press key. Means that once you start your drawing, you need to save it. Let us change and put 12 volt. Okay, and then launch the simulation once more. When you send the positive pulse in this at the base of this voltage, you discover that the relay will be energized and the light will come on. You see how you interface the low voltage with the higher voltage. In order to deactivate, we can just press open. So the base of this transistor can be replaced by a system like Arduino output or microcontroller output, because the output of microcontroller is sending the voltage level around 5 volt. That is how you can make a relay modules with the component. I call for you Bernard. We went together today. I'll show you this diagram how you can simulate. If you have a question, don't forget to ask. I will be very happy to answer you. So when there is no pulse here, you discover that the base of this transistor is polarized with the pull down resistor. Means that when there is no signal, the thing has disappeared again. That is the main problem that we had with this version of Proteus 8.11 version. The thing has disappeared. So if you have a question, don't forget to ask in the description section below. Of all our project was already finished. Switching graphs for watching, and don't forget to subscribe. Have a nice night. Peace.